Assalamu alaikum grade 6. Today we are doing the topic of our chapter number 3 3.5 logic circuit, which is on your page number 26. What is basically a logic circuit? When logic gates are combined together to carry out a particular function, such as controlling a robot, they form a logic circuit. The output from the logic circuit is checked by using the truth table. How we can produce the truth table, how to design a logic circuit from a given logic statement or a Boolean algebra, or how to design a logic circuit to carry out an actual safety function. We will learn all these three in our next upcoming lectures. Today we are learning only how to produce the truth table. For example, number one, which is in your book, is 3.5.1, and how you can produce the truth table by using the following logic circuit. Note, we have to use a dot sign at the junctions. So first of all, there are three inputs, A, B, and C. These are the inputs to the logic circuit. Therefore, there are 8 possibilities. As we already know how we are saying that 8 possibilities. We learned that when we have as much as in binary inputs, we simply take the 2's power. If we have 3 inputs, we put the 2's power 3 and we will get the answer 8. 2 times 2 4, 4 times 2 8. So we can say that there are 8 possibility binary values which can be input. To show the stepwise how the truth table is produced, the logic circuit has been split into 3 parts. The number one part 2, and part 3. Part 2 is called the intermediate values, and they are showing you that P, Q, and R are the intermediate values. They are having some for the time being they are using as an input, and they have a different values. Let's see the part 1 is saying. The part 1 is basically, this is the part 1 of the logic circuit. First task is to find out the intermediate value. We have to find out the values P and Q. The value of a P is found from the AND gate. This is the AND gate, and this is the NOR gate. That's why you are saying that the AND gates were having inputs of A and B, and they are producing the P. And similarly, B and C are the inputs of a NOR gate, and they are producing the Q. What will be the intermediate truth table? Let's see. It will be look like this. If we have a and B, they are producing the P. Don't look the C right now. Just look at the A and B value, 0 0, and you will get the 0. As we already know, when we have a both are on, we will get the P value 1. Otherwise, the rest of all will be 0. So look at this, notice it. When we have a 1 1, they are 1. 1 1, they are having 1. Otherwise, no. Okay, now what we will do, how we will find the value of a Q. How we will find the value of a Q? By using the input as a B and a C. B and C. Now you will ignore the A. You will consider B and C to get the answer of a Q. And the Q is basically a NOR gate. And you know that when we have only the 2 zeros, both inputs are 0, you will get the output 1. Otherwise, you will not get the answer. Okay, that's why we are having when 0 0, you will get the 1. Similarly, 0 1, you are not getting any value. Okay, and similarly, when we have a 0 0, look at this, we have a Q. Okay. Now let's see the part 2. The second part of the logic circuit has P and Q as an input. Look at this, and they will produce the intermediate output, which is a R. This produces the following intermediate truth table. Note, even though there are only 2 inputs of the logic circuit gate, we generate 8 binary values in the part 1, so we have to use all the values again. Okay, that will be like this. when we have a P and Q. Look at this gate, and you know that what is this gate and how it will produce. It's basically OR gate. Okay class, now we will do the part 3. In the part 3, the final part of a logic circuit has basically R and C as an input, and the final output will be the X. Which gate it is? Can you guess it? Which gate is basically is this? This is the XOR gate. XOR, XOR gate. So what is this? And in the XOR gate, if we have any one value as an input, they will produce you the output. Otherwise, they will not. So this gives the third intermediate truth table. So we will use R and C as an input, and we will get the output. I already told you that in XOR, when we have any one value is 1, they will produce a 1. Otherwise, they will not. If the same values we have, like 0, 0 or 1, 1, they will not produce you. Okay. So we putting all the three intermediate truth tables all together to produce the final truth table, represent the logic circuit, which was like this. This is the total final view of intermediate and output, and the final will be the three inputs and the final output X. You will not write the P, Q, R values. You will skip it because they are the intermediate values. Okay class, this is the end of today's lecture. And what you have to do as a home task, you have to do the activity 3.2, which is on your book page number 32. What you will do, you have to find out how they are producing the truth table of each of the following logic circuit. First A is solved. I'm solving it for you for a reference. Then you have to solve rest of the parts by yourself. First of all, you have to break into three parts, this and this, and there is no labeling like the previous one, so you can label it by yourself. This is the input A, and look at this from where they are coming. It's coming from this one, that's why we are labeling it with the B. And similarly, there is where the output is coming from this one, this is coming from the A, and this is the B and output. And there you can label it with the C and D. Similarly, in this one, in this gate, D is input and they are producing the E. And what is the input of this gate is C is as an input. Look at this, C is input and the E is output. They are producing the X. Now what you have to do, you have to identify which gate it is. In the A and B, and they are using the first one, basically it's an AND gate, and this one is a OR gate, and this is basically a NOT gate, and this is your which gate? OR gate. Okay, so you have to, before solving this one, you have to remember what is the basically behavior of all these gates. And we have how many inputs are there? Only two, so they will produce only the four values of in the truth table, whether they are will be on off, or one will be on off and the other will be on, and might be A is on and B is off, and might be both are on. As an AND gate, they give you the result when we have the both values on. Rest of the others will not be on. So we can write the value of a C as when we have a 1 1 on A as an input and B, then we will get the C 1. And what is the D output? We have to use the OR gate. What's the behavior of a OR gate? OR gate is on 1 when any one of A and B are having a 1 value. So we are writing the 0 0 and we will get the 0, and here when we have 0 1 we will get the 1, when we have 1 0 we will get the 1, when both are on even, that's when we also will get the 1. Okay, and what is this? In the intermediate we have another circuit which is basically a NOT gate, and NOT gate have only the one input. One input, what the NOT gate do? If their value is 0, you will get the 1. If the value is 1, you will get the 0. So you have to check it out. What's the input of this one? Is the D. When we in the D is when we have a 0, you will get the 1. When we have 1, you will get the 0, like this. Okay, and in this last circuit, which is basically OR gate, and you already know what's the behavior of OR gate, and we have an input C and E. So you will watch the C values and E value to get the answer of X. So what you will get, when this value is 0 and 1, you will get the 1, and when we have a 0 0, you will not get the value 0. Okay, when we have any value 1 1 and 0, you will get the answer 1. So this is the basically look of a circuit of truth table. And if you want to write the final truth table, that will carry only the input A and B, and they will produce the value of X. Okay, and you know that if how you can write 0 0 and 0 1, then 1 0, and then 0 1. Okay, what you will get, this is basically a OR gate. You will write the answer 1 0 0 and then 1. Okay, that's how you can produce the truth table. Hope you will do the rest of the parts, and good luck. Allah Hafiz.